my name is Elizabeth Anne Fitzgerald, and today me and my project partners, Adam and Melissa, will be talking about our CS151 final project, Minesweeper. So to start us off, we wanted to go a little bit over the history of Prolog. So the first Prolog program was written in 1972. The programming language gained popularity in 1977 after the creation of the first Prolog compiler. Finally, in 1989, Prolog++, which is arguably the most commonly used version of Prolog, was first released for MS-DOS PCs. Now, conveniently, at around the same time, Minesweeper was released by Microsoft, also in 1989. So this project is not only a fun challenge, but also period appropriate, as Minesweeper could have very easily been originally implemented with Prolog. So the purpose of this project is to allow players to solve problems logically at their own pace. This can be good for both kids and adults alike. Like any game, it can be a form of escapism, and it's also kind of nostalgic because it shows just how far computer games have come.
Yeah, so now moving on to the rules for our Minesweeper. It's basically the same rules as normal Minesweeper. If you click on a square with a bomb, the game immediately ends and you lose. However, if you're able to clear the board and dodge all the bombs, you win. And the number in a box represents how many bombs are present in the adjacent squares. And in our Minesweeper, we use a standard 10x10 grid for every game. And the user is allowed to generate up to 30 mines. So this actually enables the player to kind of customize the difficulty level, whether they want it to be a harder or easier experience. And the user can use the reveal button to show the squares adjacent to squares with a 0 in them. This is our implementation of Minesweeper in Epilog. In this quick demo, I'm first going to go over the rules and interface of this implementation. Then I'll play a game and demonstrate what it looks to lose. And finally, I'll play a game and demonstrate what it looks like to win. So looking at the objective of this game, the goal of Minesweeper is to reveal all squares not containing a mine on this 10x10 board below. Squares are revealed after they're clicked on, and if a square contains a mine and the player clicks it, the player will immediately lose and the board will flash red to reveal the placement of all other mines. If a square not containing a mine is revealed, that square is considered to be safe and will contain the number of mines in the surrounding vicinity. And we define that to be the 8 neighboring squares around that one square. If the player wins, the board will flash blue to reveal the placement of all the mines. Now, looking at the directions, we see that you can generate mines on the board for a max of 30 mines. So you can use this button to generate mines. And this aspect allows a player to customize their difficulty by either having a low or a high number of mines. Next to the generate mine button, we see the reveal button. And the player can click this to reveal adjacent squares to 0 squares, which are squares with 0 mines in the neighboring 8 squares around them. So to begin playing the game, all you have to do is click on a square to reveal its value, and you can track suspected bomb locations down here in the flag section. So first, I'm going to demonstrate what a losing game looks like. I'll first generate 30 mines to make the game as difficult as possible. Okay, cool. So let's just click on a random square here. And so, okay, that's pretty quick. We see that we've clicked on a mine and all the mines in the field are revealed below. So for now, I'm gonna show what it looks like to win a game. So to do that, I'll just maybe have like 2 mines of the whole board. So to start, we can just choose a random square. And right here, we see that we've chosen a 0 square. So we could use the reveal button to show the squares around the 0 square. And since we only have 2 mines, it makes sense that we're going to have a lot of 0 squares. So we can keep using the reveal button to get a better sense of the board. Okay, awesome. So I have a pretty good hunch that there's probably a mine here in the 6x6 square. So I can go over down here in the flag section and write 6, 6 to indicate that I think there's a mine here. And I'm also pretty sure that there's a mine in this square. So I can again go down here and write 2, 4 to indicate where I think the mine is. And so to win the game, I'm thinking that the mine is here and here, so I'll click on this square. And so we've won the game successfully, and we see that the mines were where we thought they were.
Now we'll talk about the ways in which logic programming can be both helpful and undesirable for this problem. So we'll start by looking at the ways in which Minesweeper aligns with the functionality of logic programming games. So first, Minesweeper has clearly defined rules. After generating the desired number of mines, the player wants to reveal all squares that are not mines using the number displayed by each safe square to detect other safe spots. If the player encounters a mine, the board explodes and they lose the game. If the player reveals all safe squares and 0 mines, they win the game. These clearly defined rules make the game straightforward to program using languages like Epilog. Next, the rules of Minesweeper can be easily defined using logical statements and numbers. Each tile of Minesweeper is either represented by a bomb symbol or a digit symbolizing the number of surrounding mines. After the player places their desired number of bombs, the value of each tile is set in stone and can no longer be changed. Then, when a player reveals a square, the program will simply check whether the tile is a number or a bomb and either uncover the number or explode the board accordingly. This action-reaction functionality makes Minesweeper a suitable game for logic programming. Lastly, unlike Minesweeper found online, our version supports varying levels of difficulty, all implemented within Epilog. We allow for 2 ways to increase difficulty, which are to either increase the number of mines present or click on the reveal button as rarely as possible. Increasing the number of mines at board initialization means that there are fewer safe squares, and so the player must be more cautious about where they click. Additionally, clicking the reveal button allows players to maximize the number of tiles revealed after uncovering a 0. Not clicking the reveal button means that players will need to manually calculate additional safe squares, increasing the chance that they accidentally click on a bomb. Because Epilog translates user actions to database updates, which subsequently updates the user interface, these were simple changes to implement. Next, we will discuss the challenges we faced while building Minesweeper. First, we noticed that the Epilog worksheets cannot handle a variety of user inputs. While users can left-click on squares to reveal mines, implementing an on-right-click or on-key-press function was more difficult since these actions are not supported by Epilog. Given these limitations, there was no way to replicate the online Minesweeper functionality that allows players to use the spacebar to flag tiles with mines. To combat this, we created a text box below the Minesweeper board that allows players to type in the coordinates of tiles that may potentially contain a mine. Another challenge we faced was automating the generation of mines upon board initialization. We had originally wanted to replicate online Minesweeper and populate the board with 10 random mines. However, since Epilog does not support for loops in the way that other programming languages like Python do, it was more difficult for us to figure out how to do this. We had tried using recursion, but the program would crash each time we instructed an operation to call itself. Thus, we decided that manually generating mines using an on-click operation would suffice and that players could use this feature to increase the game difficulty to their liking. And that was all for our presentation. Thank you all for listening.